How do digital signals travel wirelessly while maintaining clarity? It all starts with modulation. Digital modulation converts binary data into waveforms that can be transmitted over long distances efficiently. Imagine your data as a series of 0s and 1s, that's binary. Modulation turns these into waves that can travel through the air. There are several types of digital modulation. First up, we have amplitude shift keying, or ASK. ASK encodes data by changing the wave's amplitude. When you see the wave height change, that's ASK in action. Next, there's frequency shift keying, or FSK. FSK shifts the wave's frequency to distinguish between 0s and 1s. It's like switching gears in a car. Each gear or frequency represents different data. Then there's phase shift keying, or PSK. PSK modifies the wave's phase to carry information. Think of it as turning a wheel. Each phase shift represents a different bit of data. Now let's talk about Quadrature Amplitude Modulation, or QAM. QAM is like combining ASK and PSK. It changes both amplitude and phase, allowing more bits to be transmitted per symbol. This means more data in less bandwidth. Higher QAM levels like 16 QAM, 64 QAM, and 256 QAM pack even more data into the signal, making them ideal for modern communication systems. But how do we get the data back out of these modulated signals? That's where demodulation comes in. Demodulation reverses the modulation process, extracting the original data at the receiver end. In ASK demodulation, the receiver detects amplitude changes to reconstruct binary data. With FSK, the receiver maps frequency shifts back to 0s and 1s. For PSK and QAM, the receiver compares phase and amplitude shifts to decode data. It's like solving a puzzle to get back to the original message. From Wi-Fi and 5G to satellite communication, digital modulation ensures reliable and high-speed data transfer. The next time you stream a video, remember the magic of modulation and demodulation making it possible. Now you understand how digital modulation and demodulation power modern communication. Want more tech insights? Subscribe now.